We're going to start chapter 1.2 with a problem. Again, we're introducing additional strategies for problem solving. And so we highlight these first 6, but as you know, you read the book or look at the PowerPoint that goes with this chapter, you'll see that there are a long list of strategies, and sometimes we implement many at the same time. So in this case here, without a calculator, find each sum. So you can see 1 plus 3 is 4, and so forth as you see. The question is, can you quickly add up 1 plus 3 plus 5 all the way to 19? And so one of the first things, in addition to kind of making this list, looking for a pattern is what we want to keep in mind here. And one thing I recognize is I see these numbers, and those numbers should be familiar to you. They are what we call the perfect squares. And so notice if we just had 1, the sum would be 1. 1 plus 3 is 4. 1 plus 3 plus 5 is 9. 16. And so you can see if we go up to the next one, it's 25. Again, you can see the squares form perfect squares. And so the pattern that emerges on this problem here is that the number of odd numbers here, right, tell you what the sum's going to be. There's 5 odd numbers, 25, 5 times 5. There are 4 odd numbers, 4 times 4 is 16. So what we're missing in here is the 11 plus the 13 plus 17. And so 1, 2, 3, 4, 5, 6, 7, 15 plus 17 plus 19. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this sum would be 100. Again, that came from our pattern of perfect squares, kind of making a list so you can organize it, draw a picture of it. You can see we use all those strategies to find the solution. And so when would we look for a pattern? Here again, some clues when we may want to look for a pattern, especially if you're given some list of data or some number sequence gets created, then we can usually make a pattern and make a prediction. So here's another classic problem in mathematics. How many different pathways are there from A to B? And so what you're going to look at on this one here is we want to look for a pattern, but in this case we will also make the problem simpler, meaning that if I wanted to go, and here's the direction that you would look at from here to here, down to here. And so you're trying to count how many ways can I get down here. I can go here to here, that's 1. Here to here is 2. Go here, 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 here. And so you would say it's hard to keep that organized. And so one strategy before I show you the solution or you look in the textbook, right, is let's just make this a simpler problem, right? So if this was A and this is B, how many different ways could we get from? So to get from here to here, there's one way. To get from here to here is one way. And to get to here, you can go this way or this way. So are there 2 ways to get there? And then if we were going to expand that and then make it look like a little bit bigger problem, we would then ask ourselves how many different ways can we get from here to here, right? So from here to here is 1, from here to here is 2 ways, from here to here is another 1 way, right? And then to get from here to here, that's 1 way, from here to here is 1 way. And so we can start kind of keeping track of that. So how many ways to get to this point here? I can go, that's 1 way, that's 2 ways, I can go here, that's a 3 way. And so we can keep playing this game in here. And so what it ends up happening is that you end up with these numbers here that I was creating here, that you're counting the number of ways to get down to here. And what emerges if you continue, and you can read the solution, you end up with this beautiful set of numbers, which is called Pascal's triangle. I would look that up if I were you, just to get a sense of it. This is beautiful application of Pascal's triangle in so many different ways. One of them is here is just counting the number of pathways. And so you can see when you look at that pattern here, since this is a 3 by 3, you're going to go down here 1, 2, 3. Your answer would then be 20 to this question. But go ahead and take a look at Pascal's triangle. Look it up, study that, and take a look. This is a classic problem. Count the number of pathways on a grid like this.